So we treat waste in the simplest form, in the easiest form. And in the, like what our fellow friend here said, circular living. That waste can be circular living, but the choice that we take to have that circular living is going to be costly. How expensive can it be? Can we afford it? Or can we do it in the simplest way?
Thank you very much. I think there's another question here.
Thank you. So, do you have published paper about the competition?
I thank you for not believing. This calculation he needs 1,500.
Approximately, right?
1,500
So,
units.
you have 10 units in Malaysia and we need 1,000 units in only DNCC.
Okay. So, now, we're coming to your first question, whether the ash is toxic or not. We are in 14 countries, we have deployed more than 75 units. Every countries that we go to, we have sent in our test reports for provisional approval for the machine to be imported into the country. Once the machine is installed in the country, they will run their local tests using their own lab, using their own technicians. And of course, most importantly, the local feedstock. What they are treating, the type of waste they are treating locally, because every country will have different types of waste. Right? All our ash and also emissions, not only just the ash, and also emissions are tested and are validated by various international labs. Includes SGS, MyCO2, Sirin, Exova, Pony, and also Sukovindo in Indonesia. And our lab test reports, trust me enough, but validate the information, which you can visit our website or speak to our local representative here in Bangladesh. Our suppression system, in terms of ash and also emissions, is up to 99.9% efficiency. I give you an example. The two most dangerous contaminants when it comes to waste management, dioxin and furan. Sir, dioxin and furan, correct? Right? Because these contaminants is the biggest culprit of cancer. Right? Our ash suppression system, the allowable limit for dioxin and furan based on US EPA standards is 0.1 gram mg per meter cube. That is the allowable limit stated by US EPA standards. Our discharge is 0.0014 mg per meter cube. Carbon monoxide, US is...
So how you were destroying dioxin? Is the thermal destruction?
It's number one is destruction. Depending on the temperature of the ash is operating. On the average, the temperature of the ash ranges between 600 and 900 degrees C of standard operations. Depending on feedstock, depending on calorific values, depending on number of hours that you operate it can go to 1,000, 1,002 and 1,600 degrees C. For suppression of dioxin and furan, okay, key number one that you must know, the ash does not burn. There's no combustion, there's no burning. When you do not have burning and you don't have fire, the chemical reaction of your organic and non-organic items is very different. What happened in the ash is a thermal treatment. It's a high temperature drying process, very high temperature drying process. There's no oxygen in the system.
So that's pyrolysis, that's a thermal treatment.
Yeah. So so what takes place in the chamber, in the heat treatment chamber, is evaporation of vapor, number one, carbonization and oxidizations. Whatever is left is in the form of the original of everything, hydrocarbons. Right? So the releases from this heat treatment process is in the form of gases. And these gases will go through our water scrubber system, our filtration system, and our carbon filtration system. So your contaminants like dioxin, furan, heavy metals, cadmium, barium, carbon monoxide, carbon dioxide, these are suppressed within the water scrubber system and also the carbon. And this carbon will eventually remove from the ash, replaced with new one every 3 months or every 2 months, and will be treated away using the ash through the heat treatment process again. So there's no discharge to a secondary discharge to the landfill or to external parties.
How about the installation cost?
Installation, our cost is inclusive for the installation. not only installation, we will do the installation, we will do the commissioning and also the training for the people who is going to operate it. It requires a 3 days training for unskilled workers. You don't need an engineer, you don't need a highly certified technicians to do this. A normal person that we train is capable of operate, maintain and manage the Asher. In the Philippines, one manpower manages 4 Asher at 4 different locations.
You have to have the solar panels and electricity, right? So, including everything.
And also,
you very cleverly use the term energy.
Yes.
Ultimately, it doesn't matter, right? It's all about energy.
Yep.
Whatever the
keyword
resource, right?
is sustainable. We truly sustainable. And of course, it requires water. And the water that we require is not necessarily clean water. It can be river water, it can be lake water, it can be rain harvested water.
That's right. Okay, thank you.
Just a simple question from myself. We have said the installation cost. What about the operating cost per year? Because you need to study or see the economic viability.
Operating cost of the machines, the biggest operating cost for the Asher is if you go for manual, your biggest operating cost is manpower. Right? So it depends on the cost of salary for each country, which we do not know. Apart from that, the other cost that goes with the Asher will be the maintenance cost. The minimum cost of the Asher is very, very affordable. On an average, you are looking at not more than 6.5% of the investment cost of the machine. So that is annual cost, not per time. One time, the maintenance cycles is once every 3 months or once every 2 months. But you add up for a year, you're looking at average 6.5% of the machine cost. If it is using electricity, the electricity unit, the consumption is between 3.8 to 4.8 kilowatt hour, depending on the tariff in your country. In my country, our calculation is per ton electricity is averaging between around 9 ringgit. 9 ringgit will probably about 19 taka per ton of electricity cost. Water consumption is very, very minimal. 1 year you are looking at maybe around 20 liters water consumption.
Thank you very much. I think it's been a long time. This session has gone really past it. It must be really interesting and exciting. People are still sitting here. So, okay, anybody else? Any other questions? No, just one final. Any other questions for anybody? So you can have the last question definitely. Yeah.
Representative. So I think it is about particularly for hospitals. They should have their own treatment plan like Asher, and it's easily manageable. It is not possibly at this stage not applicable for DNCC, but I think for hospitals it can be done. They're making a lot of money. We know about United, Apollo and Square, right? So yeah, that's a suggestion. Possibly we can suggest the government or Raju given, if it is possible.
Thank you very much for the question. I'm just replying to your question. Shabas, the poor Shabas, they have the aspiration to become smart city as well. I mean, it is equal for all. So given that context, we have 319 different small cities and Purushabhas in the whole Bangladesh, and out of which, as per my rough calculation, I have seen that the Asher can be applicable very nicely in 200 cities. Thank you.
Yes, I think that there will be a lot of conjectures and areas where this can be applied. But I think that temperature, even though it doesn't burn, is 600 to 900, and that's the dangerous range at which these chemicals are formed. And you have to maintain a temperature above 800 continuously to burn up this thing, or you collect it in the water. 400. So 400 is the temperature at which it forms. At 4 to 600. But to ensure that it burns out, you have to. But anyways, I think those are not the details that we like to discuss here right now. But I'm sure that your process works. But we also need to see the reactions that goes on over there. by which you're decomposing that. And also, like, you have a sort of a scrubbing unit. So that scrubber would take out many of the things, so that's not a problem. But then you will have a effluent which has all this sort of pollutants. Why are you saying there won't be any liquid pollutant? There will be a liquid pollutant.
That's the beauty of the ASHA. The water scrubber system comes with a self-cleaning and self-treatment system within the ASHA. So what we do is we take out the dirty water that we use for the water scrubber system, we clean it and we recycle and we use within the system. There's no water discharge.
Okay, thank you very much. I'm sure that if we had more details, we would understand that. It's very difficult because this is an innovative technology and it is a bit complicated because you're talking about reactions and all these kind of things. But I'm sure it works, and I think that if you can convince our sort of policymakers that this can be tried in Bangladesh, I would support it. I would definitely support it because right now we are in a state in Bangladesh where we are getting swamped with waste, and we need to come up with a solution that works for us, which is cost effective and will also. Our main constraint is land. Our main constraint, like even with solar energy, but we find we can't expand solar energy because we don't have enough land. So whenever a technology is given to us which does not require land, so much land, then we should consider it. And I think that what you presented is very attractive, and I think that I request the government to consider it. And so along with all the other technologies, because we are at the very beginning and of where we are starting to manage MSW so that we can become a smart city. I think that the first requirement of being a smart city is to tackle air pollution and municipal solid waste. Without these things cleaned up, we can't go anywhere. Thank you very much for listening to this session. I think that we have taken double the time in this session, but I see people are still sitting there sort of attentively listening to this. I enjoyed the session. I learned some new things, and I'm sure that you also did. And the policymakers are also here. They have also taken notes, I'm sure, and will use these kind of technologies to solve our MSW problems. Thank you very much.
Thank you so much. Thank you so much. Now, I would like to request our Red Carpet's Director Marketing, Mr. Fatima and Mr. Maruf, to hand over the memento to our panel chair and special guests and discussants. Thank you so much.
Thank you.
He's ready, and we would like to request Ms. Fatima to hand over the first to Mr. Peng.
Thank you.
Mr. Engineer Mohammad Zahinul is now.
Thank you.
Mr. Mohammed Samiul is now Managing Director of Ubique Corporation Limited. Please step forward.
Thank you.
Thank you so much.
থাকবেন সবাই থাকবেন থাকবেন থ্যাংক ইউ